In this last video for periodic table, we're going to look at the properties of group 0 and transition elements. Now first we're going to look at group 0 elements. Group 0 elements are also given a special name called noble gases. So if we look at the electronic configuration of the elements in group 0, I hope you can realize that they have a fully filled valence shell. So what does that mean? It means that they are stable on their own. Right, if they are stable on their own, the atoms can exist on their own. We call them monoatomic. That means they can exist as a single atom. Okay, and because they are stable, there's no need for them to combine with any other elements. We say that they are inert. They do not undergo any reactions. And then the next thing is that since they are in group 0, they are actually non-metals. And we have learned in chemical bonding that non-metals have simple molecular structures, and because of their simple molecular structures, they have actually a low melting point and a low boiling point. So because of their low boiling points, they at room temperature, all of them are actually gases, and they are not just gases. We need to remember that they are colorless gases. Right, so by the name noble gases, what does it mean? It means noble meaning they are inert, they don't undergo any reaction. Gases indicates that they have very low boiling points. Now other than the general characteristics, what is required in this section is that we need to know a use for each noble gas. Helium is frequently being used to fill balloons, especially if we want the balloon to float, because helium is less dense than air. Neon is used to make neon lights. Alright, at this point, some students may say that, hey, didn't you say that noble gases are colorless? So, but neon lights, they are highly colored, they are highly bright. So is there a discrepancy here? Answer is no, because in order for neon to give off that color, we need to first put a very strong current through it. Alright, we need to excite the electrons to an outer valence shell. So under normal conditions, your noble gases are all colorless. Lastly, argon. Argon, we use it in the lab a lot as an inert gas to provide an inert atmosphere. Right? What do I mean by that? Now, for example, certain reactions they are very sensitive to oxygen. So if there's presence of oxygen, your reactants might react with oxygen instead. So how do we carry out such reactions? Is that we need to flow through an inert gas. Okay, and the inert gas that we use is often argon. A less expensive alternative would be nitrogen. So as mentioned, noble gases have low melting point, boiling points. They exist as monoatomic gases. They are colorless, and then they are inert because they have a fully filled valence shell. They have no tendency to combine with another element. Next, we're going to look at transition elements. What are transition elements? If we look at the periodic table, there exists a block of elements between group 2 and group 3 where they are not assigned any group numbers. Okay, this block of elements is known as transition elements. Okay, and if you were to analyze the elements in this block, they are actually all metals. Right, so therefore we call them transition metals as well. Now earlier we have also encountered transition elements in chemical bonding. Why? Is because without a group number, we wouldn't be able to predict the charge on a transition metal ion. So if you can recall, for transition metals, how do we indicate the charge? Is that we put a Roman numeral in their name. For example, iron 2 chloride. So the 2 in iron 2 chloride simply means that iron has a charge of Fe2+. So now we're going to take a look at some characteristics. There are actually 5 characteristics of transition metals that we need to remember. Firstly, if you now take a look at the melting points of your transition metals, chromium, manganese, iron and copper, these are typical of metals. You see them in the thousands, right? Contrast that to your group 1 elements. You find that group 1 elements have very relatively low melting points. Your transition metals have high melting points. Next, we look at the densities. Right now the density is around 7 to 9, so they will actually sink in water. So this is characteristic of most metals: high melting point, boiling point, high density. The next important feature of transition elements is that they can form ions with variable charges. So what do I mean by that? For example, if you look at iron can actually form 2 types of compounds: iron 2 chloride and iron 3 chloride. So what it means when we have iron 2 chloride is that the charge on iron is Fe2+. Similarly, for iron 3 chloride, the charge on iron is Fe3+. Okay, so for a transition metal or for a transition element, it can actually form ions with different charges. Alright, other examples include copper. Copper can be copper 1 or copper 2. Alright, similarly, lead. Okay, lead can be lead 2 or lead 4. Okay, so this is unique to transition elements. If you think about other metals, for example sodium, can sodium have any other charge other than plus? Answer is no. Can magnesium have any other charge than 2+? Answer is no as well. So it's unique to transition elements that they can have ions with different charges. Alright, so therefore we have different formulas for the compounds as well. Now the next important feature of transition elements is that they form colored compounds. Now take note of the word compounds, because the elements themselves, the transition metals themselves, they appear as normal metals, so they are silvery or grey. But when they form compounds, when they combine with other elements, they exhibit a range of colors. Alright, you should have encountered copper sulfate in the lab, and if you can recall, it's actually a very nice blue solution. Alright, iron 2, compounds containing iron 2, they are usually green in color, and compounds containing iron 3, they are usually yellow or reddish brown in color. Okay, so what you see in this diagram here is actually manganese, which is a transition element. Alright, and manganese, in this case, manganese ion exists in different oxidation states, from different charges from +7 all the way to +4. Alright, and you can see that for manganese ion with different charges, different oxidation states, it actually exhibits a slightly different color. Now the last feature of transition elements is this, that they are good catalysts. The transition elements themselves and the compounds are actually good catalysts. Now what are catalysts? Catalysts are substances that speed up a reaction. Right, at this point we have yet to learn many catalysts, but in the future we will see that there are many reactions that upon adding a catalyst can cause the reaction to become faster. Alright, and more often than not you will find that the catalyst that's being used is either a transition element or a transition element combined with another element to form a compound.